right. Good morning, everyone. Thanks for joining us today. We'll get started here. Looks like a bunch of people are joining. It's fantastic. Thank you. Well, welcome to our webinar. May the 4th of Earthquake Early Warning be with you today and on the 4th of May. Thanks for joining us. So I'm going to get started here. All right, so we are going to be talking today about what ShakeAlert Earthquake Early Warning is and how it works, how people can get alerts and what they can do to protect themselves. And we have a whole host of ShakeAlert licensed to operate partners, companies who are going to share their information about their products and services that they provide. So our presenters today are myself. I'm Maximilian Dixon. I'm the Hazards and Outreach Program Supervisor here at Washington State Emergency Management Division. We have Dr. Harold Tobin from the Pacific Northwest Seismic Network. We've got Boone Spooner from Google, Matthew Strabe from Global Security Systems, Alert FM, Francisco Catala from SkyAlert, Dan Irvin from Various Incorporated, Dan Dalton from Valcom, and Taylor Stockton from RH2 Engineering. All right, so some housekeeping here. So we are going to be holding questions. We're answering questions at the end after all the presentations. And then there will be some folks from the team here that might answer some questions during the presentation if there's some simple ones. But please, for questions and comments, you can submit these in the questions and answer box that's at the top right, the upper right corner. Also, captions are available by clicking the settings icon in the lower right-hand corner. All right, so let's get oriented here. Now, Washington State is earthquake country. We have the second highest earthquake risk in the United States, and we also have one of the highest tsunami risks in the United States from both local source tsunamis from Cascadia Subduction Zone, Seattle Fault, and distant source tsunamis, say from Alaska or Japan or even New Zealand. So most folks hopefully have heard of the big one, the Cascadia Subduction Zone earthquake, and this is the one that we're most worried about. So it's a 700-mile long fault from northern Vancouver Island down to northern California. It ruptures about every 300 to 600 years. The last one we had was 321 years ago in 1700. There's about a 15 to 20% chance that we will have a large earthquake on the Cascadia Subduction Zone fault within the next 50 years, and this is going to be felt the entire West Coast. You could have shaking up to 3 to 6 minutes, which is going to seem like forever. So for context, Nisqually, if you remember that 20 years ago, 45 seconds. So 3 to 6 minutes, it's going to seem like forever. And of course, it's going to create a huge tsunami that will hit the outer coast within 15 to 20 minutes after the shaking starts, and potentially thousands of aftershocks for years afterward. All right, so now we're going to transition into more about ShakeAlert Earthquake Early Warning System with Dr. Harold Tobin.
Good morning, everyone. Yes, my name is Harold Tobin. I am the director of the Pacific Northwest Seismic Network, which is based out of the University of Washington here in Seattle. I'm also a faculty member at UW. And as part of the Pacific Northwest Seismic Network's role, I'm the state seismologist for Washington. My task this morning is to tell you a little bit more about our earthquake hazard in Washington State and what this new public safety system that goes live for early warnings next Tuesday is really all about and how it works. So next slide, please. First of all, as Maximilian just said, there is no doubt that our region is earthquake country. We've had significant and damaging earthquakes in our history in relatively recent times, including the 2001 Nisqually earthquake, but also in 1965 and in 1949 with similar events that took place at that time. So as our region grows all the time, we saw the census numbers that came out yesterday that Washington has continued to grow in population and grows in infrastructure. And so more and more of us are at potential risk from damage from these hazardous events. But there's a lot that we can and are doing about that. And one element of all of these things is going to be earthquake early warning. If you go to the next slide, I want to just talk a little bit about the the potential for that hazard and why it's important to invest in these kinds of systems like earthquake early warning. We talked about the potential for loss of life, and those previous events all caused injuries in the past. The potential for an offshore earthquake like the Cascadia subduction zone that Maximilian just alluded to is a much larger event. Fortunately, happen less frequently for us, but with potentially devastating impacts. So the likelihood of another event like the Nisqually earthquake actually in the next 50 years, let's say in our lifetimes, is much greater than the likelihood of an event offshore. And it's estimated at something like 85% over the next 50 years that we would have a similar earthquake to Nisqually in our region. The eastern side of the Cascades also has experienced earthquakes in relatively recent history with the 1872 around Lake Chelan. So we have all of these earthquake possibilities. FEMA has actually estimated the hazard, and California has the highest estimated potential financial losses, damaged infrastructure from earthquakes in the USA, but Washington is second, as Maximilian said. And this number here just really puts that fine point on it, I think. This is not the overall potential hazard from an earthquake in our region, but it's the annualized version of those losses from taking those probabilities of earthquakes and averaging them out. So every year, there's the potential for the occurrence of a loss in Washington and Oregon of about $700 million, about $450 million of that in Washington alone. That's, of course, not to say that earthquakes happen all the time. It might be decades, but when they happen, there are billions and billions of dollars in potential losses, not to even mention, of course, the potential for injury and loss of life. So, so it's very important for us to do all of the things we can for safety systems for these potential earthquakes. If you could go to the next slide, please. Okay, the slide order is a little different than what I anticipated. We have been adding stations to the Pacific Northwest seismic network over the past decade, and in fact, especially since 2015. And what you're seeing on this map is a plot of the locations of seismic stations growing over the period of time from 2015 to the present. The reason we're adding those stations is that these are the ways we actually detect earthquake events in those first few seconds after they begin to occur. So the ShakeAlert system, the fundamental principle of how it operates is that it's not earthquake prediction. We have no means to predict earthquakes before they occur. Some earthquakes have foreshocks, but the vast majority of damaging earthquakes do not show us foreshocks, and the experience from all around the world demonstrates that to us over and over again. So that we don't have a detection method for an impending earthquake, let's say in the span of the next hours, days, weeks. What we have are those kind of long-term forecasts of the possibility of earthquakes that we alluded to just a few minutes ago. So instead, what the ShakeAlert system is designed to do is detect earthquakes as they begin very close to their epicenters, so that as the damaging seismic waves spread out from those epicenters, then the system can calculate that an earthquake has occurred, detect it, calculate how likely the area is over which damaging shaking will occur, and issue a warning that can be both sent out to potential infrastructure partners, the technical users that you're going to hear from in a few minutes with examples of how we use this kind of information, and also mass alerting to the general public through, let's say, mobile devices and other methods. And that's what's really coming out next Tuesday, is we're turning the switch on essentially to allow for that kind of detection to go out to the public. We operate now over 230 seismic stations in our state. Actually, today's number is 239. We're adding them literally every week right now. We have a number more to develop and install to fill in the locations on that map to cover the entire state with density of stations that will allow for earthquake early warning. The highest concentration is in the Puget Sound and west of the Sound on the Olympic coast and the southwestern coast, because of the combination of where the largest earthquake hazard lies with the Puget Sound earthquakes like we saw before, and also with the offshore subduction zone, and also where the highest concentration of the population is. The ShakeAlert system is capable today, and we've been running it in test mode for a while, of doing the detections for all of these high population areas and highest risk areas We're not done building out the network though, and that's why we're adding about 100 more stations to make sure that we fill in the potential gaps where we do have the capability of alerting today, but we can speed up the time to those alerts and improve our ability to get the best possible warning out in the future. So we're not done building, but we also have a system that's highly capable today, and that's why we're going live with it. We have been operating the stations out of the University of Washington for a very long time. We're also a big part of the research team that is really a national team with the Federal U.S. Geological Survey, as well as our partners at the University of Oregon, University of California, Berkeley, and Caltech, who have developed and designed this earthquake early warning system. Next slide, please. So we are at a point now where the ShakeAlert system can create earthquake early warnings literally in a matter of a few seconds after the initial detection of the seismic waves by the closest few stations. We need 4 stations to detect an earthquake to ensure that the algorithm that runs on computers here at UW campus and also at Berkeley and at Caltech can identify that it's really an earthquake and not a spurious signal of some sort. We don't want false alerts to go out to the greatest extent we possibly can avoid that. So we detected at least 4 stations. And the colors on this map show the area in which that initial detection at the 4th station away, so 4 stations worth of detection, is well under 10 seconds. It turns out that the seismic waves that are most damaging from the earthquake are the slower moving, what are called S waves. We detect the P waves, which move faster and therefore tell us an earthquake has occurred and how big it is and where it's located, but don't actually do the damage. And we use the difference in time and then the way the waves spread out like ripples in a pond away from that epicenter to warn people who are further away. In the case of something like the Nisqually earthquake, the earthquake was deep enough that the P waves reached the surface, and even right at the epicenter, right at the location above where the earthquake started, we still have about 10 seconds of time in between the first detection of that earthquake at those stations and when the damaging waves get to the surface of the earth. And then as you go further away from the epicenter, you have more and more time. So those seconds don't sound like much, but they're precious seconds to generate the earthquake early warning. As you can see, the eastern part of the state still has quite good detection times in less than 20 seconds or so, but we're expanding again the network to cover those areas as well. It turns out that once the detection occurs, the actual algorithm that calculates that an earthquake has occurred and decides whether to issue a warning can make that operation in anywhere from literally fractions of a second to only, sort of 1 to 3 seconds is typical, and in some cases up to 4 or 5. So there's ample time based on the speed of modern telecommunications to do this and the speed of modern computer systems to generate the warning and do it reasonably accurately. For an earthquake off our shores, then the warning time increases for the populated regions of the state and even for the folks at the coast because, again, of that arrival of the fast moving but not damaging waves first and then the damaging ones coming slower behind them. Next slide, please. Here's an example of an actual warning that has occurred. The ShakeAlert system was live in California starting in October of 2019. We've been operating the system in a test mode here in the Pacific Northwest during the same period of time. California has more frequent earthquakes, and therefore it's been a great test bed to see what the real live performance of the system has been before we wanted to take the step of going live in our region. Here's a great example. September 18th, 2020, a magnitude 4.6 earthquake occurred literally in the center of the highly populated Los Angeles basin. And the alert was generated and released 4.7 seconds after the 0.0 second moment when the earthquake began, very quickly. You're going to hear from Google in a few minutes about how the earthquake early warnings are delivered through the Android system. So that's a screenshot of the Android system that alerted 2.2 million cell phone users at that time, giving them a chance to take some protective action when the earthquake occurs. The alerts, as you'll hear in a few minutes, will also go out through the wireless emergency alert system, which operates, which can send it out to all carriers and all types of phones that are able to receive those WIA alerts. And WIA was not activated for this event because the threshold for WIA alerting is a little bit higher at magnitude 5, and the threshold for Android alerting is just a little bit lower. But the system successfully worked very well in this, and actually a number of other events, more than a dozen other times the system has been activated in California. Next slide, please. Okay, well, I want to say that, we want to cover questions about what you can do with just seconds of warning. It doesn't sound like much, but there's a lot of research that's gone on to understand how earthquake early warning has worked in other states, other countries around the world. Japan has had an earthquake early warning system for about a decade going. There are warnings operational in Mexico and new systems coming online in other places. Taiwan is another. And we've found that even with a few seconds of warning, people's behavior is very different. Instead of panicking when they feel the shaking start, not knowing what to do, it gives you that moment to collect your thoughts, take those life safety operations, and you're going to hear more about those in a minute, but drop cover and hold on, and so on. So that's a key part of the immediate messaging, and that's why we're going live with the public alerting starting next Tuesday with the wireless emergency alert messages in the Android operating system. The second big component that you'll hear a lot about from some of these examples that are coming up in this webinar this morning is that the alerts can go directly to automated systems that will take automated actions in order to protect those vital systems for public safety, like, for example, the water supply, potentially utilities, transportation systems, life safety organizations like the fire companies and so on, that can have automated actions that don't require any human intervention, but just go ahead and take those actions. One very important example that's happened here in Washington State is the installation of a ShakeAlert direct connection to a school PA system you'll hear about in Stanwood Elementary School as a pilot program. And we're going to focus a lot on increasing safety in schools by using the ShakeAlert system as warning system in schools. So those are examples of installations that have already happened or are coming online soon in the state of Washington. With that, that's just a little bit of the flavor of how ShakeAlert works, and I'll be happy to take questions as we get to the end, and I'll pass it back to you, Maximilian. Thanks very much for your attention, everyone.
All right, thank you, Harold. We'll do a little transition here. So I am going to talk to you about how to make sure that you can get wireless emergency alerts on your mobile phone, and also how to protect yourself. So wireless emergency alerts. So you may have recalled that we had a test of the system on February. So hopefully if you were in King, Pierce, or Thurston counties, you received those messages. But let me walk through this a little bit. So it's really important on your Apple, if you have an Apple iPhone, to go to your settings and notifications, scroll to the bottom of the screen. Under government alerts, tap emergency alerts, public safety alerts. Basically, if you look at the picture here in the bottom left, just turn all of those on to swipe them to the right, so that make sure that you are able to receive these alerts. So that's really important, otherwise you will not get them. For if you have an Android phone, there's a number of different ways, but here's a couple. So use the search function in settings to find emergency alerts or public safety messages. It also may be within your messaging app instead. And just, again, make sure all of your alerts are turned on. So if you look at the bottom or the right here, there's an image there, kind of gives you an idea of what some of the different types of alerts are. So make sure that they're all turned on just to ensure that you are able to receive these alerts. So please go ahead and check your mobile phones after the presentation. Thank you. Now, what does the message look like when you get it? Right, so similar if you've received an Amber Alert, right? You know, hopefully it gets your attention, but the message here is both sent out both in English and Spanish, depending on your settings, and so it says earthquake detected, drop cover, hold on, protect yourself, and USGS ShakeAlert. So this is it. This is what you're going to see, and you will have seconds to react. So I'm going to tell you what you should do. First, do not try to run. Most injuries are caused by either things falling on you from within a building or outside of a building, or you falling down, being knocked over while you're trying to move during the shaking. So please do not try to run. And here's a good example of why not to. So if you see this person here at the desk, so they're starting to detect there's a earthquake is starting. This person picks up their baby, going out the door, and there you go. So if this person had grabbed their baby and just gone under the desk here, then they would have been fine. But I really don't know what happened to them after they went out the door. So please, please do not try to run. Also, here's an example from Nisqually earthquake. This is Phoenix Underground, downtown Seattle. The owner of the bar picked up his dog, ran out of the building into the street. Just a few seconds later, after he got to the middle of the street, all those bricks from the facade fell down on the sidewalk. So if he'd been a little bit slower, then that would have been a bad situation. And there really wasn't, much damage inside. So please do not run outside of a building. Here's another example from Christchurch. I'll get this to work. This is a video from Christchurch, earthquake. So if you notice, they're outside, and the top right, this building here is an unreinforced masonry brick building. It did not collapse, but the facade came down. So if you had run out of the building, someone had run out of the building or near the building, then that would have been a very bad situation. But being out here in the parking lot was safer. Hopefully, folks will also drop cover and hold on. Let me get into this. So when you feel shaking or you get an alert, remember, you will have seconds, right? But it does matter, and you can do this. Please drop to the ground, get under something sturdy, or something to protect yourself. Get somewhere nearby, safe. Cover your head and neck, and hold on. If you're underneath something sturdy, hold on to that so it doesn't travel away from you, so it continues to protect you during the shaking, or hold on and brace yourself for the shaking. So drop, cover, and hold on. And I have some examples here in different different situations. If you're in bed, and hopefully you have removed heavy picture frames and bowling balls from your shelves right next to your bed. Hopefully you've moved all that or secured that. But we've seen from studies that you should stay in bed. So if the earthquake happens in the middle of the night and you're in bed, put your pillow over your head, curl up into a ball, and hold on and ride out the earthquake, because you're more likely to survive and not get injured if you stay in bed. Outside, get away from things as quickly as possible that could fall on you. As soon as you can, get down on the ground, cover your head and neck, and ride it out. If you're driving, emergency brake. Well, first of all, you want to do is you want to put on your flashers. You want to pull over safely as possible, somewhere safe, not under an overpass, not under a tree or next to a telephone pole, and then put on your emergency brake, cover your head and neck, and ride out the earthquake. And then if you're in a wheelchair, put on your brakes, cover your head and neck, and hold on as best you can. And of course, anywhere, try to get to safety and protect yourself as best you can. So we want you to practice so that you don't freeze, so that you can take those precious seconds and do what you need to do to protect yourself. And this is how to do it. This is Alaska earthquake, 2018. All the kids and the teacher got under their desk within less than 5 seconds. So they've trained, they did the right thing. All right. So as I mentioned, Cascadia subduction zone earthquake also causes a huge tsunami, or can, and of course we've called this the big one. So I'm going to talk to you about what to do to protect yourself if you're on the coast. So there's a few myths here. You're safe if you're not on the beach. That's not true. The waves can be really high, and it may not. The first wave may not be the highest. So you got to keep going basically inland or up on high ground. Now, you can outrun a tsunami. No, you cannot outrun a tsunami. They're 25, 35 miles an hour once they reach land. So really, really fast. And of course, you can't surf a tsunami. So those are all myths. Facts. So Tsunamis can travel many miles inland, up river channels, again, 25, 35 miles an hour. And it's like a wall of concrete or cement that's coming towards you. It's the entire ocean moving with debris, sand, rocks, logs, boats, houses, you name it. Everything's in there. So what do? So once the ground stops shaking and you feel that you can get up and safely move, as soon as that happens, grab your go bag. Hopefully you have a go bag ready with you with some key essential items that you've prepared beforehand, and head to your tsunami evacuation route as quickly as possible on foot, because you're not likely to be able to use a vehicle because of damaged roads and landslides and traffic and town telephone poles, trees, etc. So plan to go on foot as quickly as possible. Do not waste time checking for alerts or verifying or calling people. Just go. Then, like I said, be prepared to go by foot. And also, this helps leave routes open for emergency vehicles and first responders or folks who are trying to help people to get to high ground, folks that can't walk on their own. So please go by foot. That's your best option, most likely to work to be able to get around all of the obstacles and navigate. Then once you reach to high ground, stay there, right? So do not go back in the inundation zone, because tsunami waves can come in. It's a series of waves over potentially 24, 48 hours. And again, the first wave is not necessarily the highest. In the Tohoku earthquake and tsunami in Japan, 2011, I believe it was the fourth wave in many locations that was the highest. And so please do not go back in there. It's a dangerous area until local authorities have said it's okay to go down back into the inundation zone. So how do I sign up for alerts? So here is key information, our key websites and resources. So our earthquakes page here, mil.wa.gov/earthquakes, gives you all kinds of information on how to connect to the companies that are going to be presenting here, the LTOs, all their products and services, and a lot more information about earthquake risk and what to do here in Washington State. And then, of course, our mil.wa.gov/alerts page, that gives you all the great information on how to receive wireless emergency alerts, how to receive ShakeAlert messages, and all that. So please go check that out. And with that, I will move to Poon with Android. And
great.
Go ahead.
Well, thank you. Good morning, everyone, and thank you for the time here. Congratulations to ShakeAlert in Washington for getting ready to launch this. Next slide, please. So I'd like to tell you a little bit about Android alerts and the partnership with ShakeAlert and the types of things that we'll send. Obviously, our goal here is to save users seconds so they can be able to react with confidence when an earthquake starts. Next slide, please. We've specifically developed 2 alerts for Android users that correspond to specific MMI levels. All alerts are active for magnitude 4.5 plus earthquakes. And the first alert, which I'll show in a second, is called the Be Aware alert. This is for weak or light shaking. That's MMI levels 3 and 4. And most folks can feel this type of shaking. And the goal of this alert is to really inform users about the shaking that will be coming to them. The second alert, what we call the Take Action alert, is for moderate to extreme shaking. This is shaking you definitely feel and could be dangerous. And the alert we've designed is designed to get our users' attention and encourage them to take action immediately. Next slide, please. So I mentioned the Be Aware alert. This is the alert we send for MMI levels 3 and 4, so light shaking, weaker light shaking. And that alert, as you can see, is a notification on Android devices. This is a standard Android notification and respects all do not disturb settings. So if you have the volume off, you won't hear the volume. If you've got your vibration off, you won't feel the vibration. And again, the goal of this is really to warn users about light shaking coming soon. Build trust in the alerting system so they know that the system is working and giving them information, and then take them to more information about earthquakes, about earthquake safety, information about the earthquake, where it took place, etc. And I'll show a screenshot of that later. Next slide, please. The Take Action Alert, again, this is for moderate to extreme shaking, is really designed to make users instantly aware of dangerous shaking coming along. This alert will turn on the device, the screen of the device, will present on the full screen and make a loud sound to get your attention. So basically it will break through the do not disturb settings to make sure that you're aware that earthquake shaking, heavy or moderate to extreme earthquake shaking is coming in. You can, of course, then tap on it to dismiss it and get more earthquake information. Next slide, please. When you interact with either of these alerts, the standard notification on the left or the red alert in the middle there, it will take you to the earthquake safety information page. This information page has a couple quick guidance steps for a user to get their shoes, check for gas leaks, and avoid damaged buildings. It's just quick tips to stay safer, as well as an earthquake map of where the earthquake took place, so you can sort of stay in the knowledge of what's happening. And then below that, you can't see it here, we'll see it on the next page, a bunch of additional earthquake safety information. I do want to note that this information is cached on the device, so it's saved on the device. In case your internet or Wi-Fi does go out, you can always access this information and have your safety information at hand. Next slide, please.
Sorry, Boone, 1 second. And how could you please explain how folks make sure that they receive these alerts once it goes live on May 4th?
Sure. So Android devices will have this automatically turned on if they're in Washington. Users can, if they so decide, can go to settings, location, earthquake warnings, and they can opt out of it if they like to.
Thank you.
Next slide, please. Here is the information details page. So here is where I'd sort of presented earlier, the type of information will be in the earthquake safety info page. The one part that wasn't present earlier is the more safety tips, where we have a number of different things about getting emergency supplies, moving to higher ground as mentioned for tsunami safety, etc. Next slide, please. One more piece I wanted to talk quickly about is, it is possible that you'll get an alert after shaking has taken place, or for example, you may not have your phone near you when an earthquake takes place and you come back to it at a later time. For both of these situations, we essentially downgrade the alert, but leave it on your screen so that an earthquake took place and you can still find the information about what happened. So in this case, we say earthquake occurred nearby, so it's in past tense. If you tap on that, you will get the same experience as before. You'll get all the earthquake information, where it took place, all the safety steps. And again, the goal here is to confirm that yes, you did feel an earthquake, and to provide that additional information to users. Next slide, please. You mentioned earlier, where could you find information about turning this on or off or see a demo? Again, if you go to settings, location, earthquake alerts, you'll see a page that sort of in the middle there where it says earthquake alerts. You can toggle this on or off. You can also press the see a demo page, which will enable you to see the take action alert, the bright red alert with the sound, so you can experience it and know what to expect. Next, please. And this is just sort of a page that can be used and sort of referred to understand the different alerts that we send, 3 styles of alerts, and then use it in the future. And that is it.
All right, thank you, Boone. And up next, we have Matthew with Alert FM.
Yes, hi, I'm Matthew Streb with Alert FM, one of the founders. I'm the CTO and the Executive Vice President. And next slide. Next slide. Yeah. Can you go back one, please? Sorry. Oops, okay, it's out of order. Okay, anyway, let me tell you, next slide, please. So let me tell you a little bit about our company. We were founded in 2003. We're validated by FEMA and Northrop Grumman. We basically, what we do, we provide FM radio infrastructure. We piggyback on FM radio infrastructure, which allows us to send out messages even if the internet, the power, or the cellular network fails. So it's basically the same text information that you would get on your car radio that for song and title information. What we've done is turn that into a alert channel. Currently, we're partnered also with the Weather Service, Amber Alert, and other alert local, county, state content providers. So earthquake is really, alerting is really an add-on. We had a CRADA with USGS 5 years ago, and since then we've had pilot programs mostly in the LA area, which then resulted in a license to operate this year. We're working in 14 states across the country, and we have our products include the three that you see here. So on the left is Alert Studio, which is an alert origination tool that originates for EAS, all the IPAWS capabilities, including WIA, also for social media, and then also for the Alert FM text-based alerting messages. And then GSS Net is our wireless network. So all of the radio stations, we operate on commercial FM radio stations. We piggyback. So at every radio station, we have a satellite downlink. So we have a nationwide satellite network that connects all of our stations. And we've demonstrated that we can send messages in less than 5 seconds, which makes this really interesting for earthquakes. So we're not encumbered by switching networks or other data sessions or phone calls. We have a dedicated network that's purpose built for sending out these messages. And the advantage is that we basically can send messages out broadcast. So that means whether we have one receiver or a million receivers, all of the receivers get the message at the same time if they're addressed. So each receiver is addressable. And we can also send them to different groupings. So the system is 100% configurable. On the right side, Alert FM, that's our brand. And that's the name of the network and the receivers, the commercial brand. Next slide. So this is an example of our message creation tool. So we have the ability to create a polygon. We're taking the contour map data from the earthquake ShakeAlert system. So we're actually sending out coordinates. So the receivers will then take their coordinates and then process them to understand whether or not they're inside or outside of the area of interest. Next slide. This is our signal flow. So on the left, you can see this is we're consuming messages from all the different sources. It's more than that. It includes ShakeAlert. And then we have that's sent to our uplink through our cloud servers on AWS. And then we push that out to all of the different users. Next slide. This is an example. So this is the receiver, what we call our personal receiver. And a siren. What makes it really interesting is that this runs off of a AA battery. So typically you'd have it plugged in, but if there was an earthquake, you would grab it, or if there was a fire and you were evacuated, you would grab it and would continue to operate. As long as you can hear the radio station, you're still going to get messages. We have another receiver, which is our public receiver, which hangs on the wall, runs off 3D batteries, and it will last 4 years. So that's useful for schools, hospitals, and has the same features with a loud siren and strobe light. So this receiver here that you see here, it sells for $65, includes a cable, programming, and there's no contract or ongoing message fees. And the same thing for the public receiver, which sells for $340. So that ends the presentation, and thank you for your attention.
Great, thank you, Matthew. And up next, we have Francisco with SkyAlert.
Hi. One second, it's unmuting. There you go. Hi, I'm Francisco Catalá from SkyAlert. We have a couple of earthquake early warning solutions that I would like to share with you. Please, next slide. Okay, first of all, SkyAlert was founded in 2011. We operate mainly in Mexico and the US. Our headquarters in the US are in Berkeley, California. And in between the US and Mexico, we provide services for over 400 businesses. With our technology and training, we help organizations to significantly decrease the number of injuries and fatalities seen in the aftermath of an earthquake. What we try to do is to provide a system for companies to automate processes at the moment of a seismic event. Whenever there's a signal coming from the USGS ShakeAlert network, our receptors are able to start automatic processes to shut off gas lines. Oh, I think that's the next slide. Next slide, please. There we go. That's the receiver. The receiver will get two main the information from the earthquake, two main data points, which is the intensity at the location of the device, which is very important, and the ETA of the earthquake. With this information, our clients are able to automate processes depending on the ETA and depending on the intensity. We help them configure these thresholds so they can, for example, for an extreme intensity or extreme shaking expected, you can shut off gas lines, can start elevator procedures to move to the nearest floors, and open emergency doors, etc. We have several success cases in the U.S. with the first responders, airports, and the Department of Energy, where they connect their infrastructure to our device so that when the alert is received, they can configure these kind of behaviors. Also, the device allows our customers to make periodical earthquake drills because what we've realized is that having the alert is not enough. The personnel need to be prepared on what to do in each situation, because we cannot automate processes, but the human factor needs to be addressed as well. So we provide also training and for training, yearly training, and also we provide guidance for depending on the location, if it's a building, if it's a factory, one-story building, etc. Next slide. So how can your organization be prepared with SkyAlert? Some of the success cases that I talked about: opening emergency doors, turn on emergency lights and strobes, pause the production on factories, shut off gas valves, and we provide yearly training to the personnel, so they not only know how to react to an earthquake, but also how to manage personnel during or other people during a seismic event. And this has become very successful here in Mexico, where there's every year we have at least 1 or 2 6 magnitude or bigger earthquakes. So we have all kinds of scenarios here in Mexico, from Mexico City, which is usually far away from the epicenter. Here in Mexico City, we have around from 40 seconds to 120 seconds to react, which is fantastic. And the scenario allows for people to evacuate buildings. But for cities near the coast, like Acapulco or Huatulco, there we have several hotels which the alerts will have maybe 3 or 4 seconds between hours until the earthquake movement arrives, right? So the procedures are completely different, and we have experience with both. And next slide. So preparedness is the key to avoid disasters. Be earthquake ready, and we can schedule demos to any customers. You can find us at SkyAlertUSA.com or drop us a call or an email, etc. Thank you.
All right. Thank you, Francisco. And up next, we have, Dan with Various.
Good morning, everyone. My name is Dan Irvin, Executive Vice President of Various Inc. And next slide, please. We have been involved with Pacific Northwest Seismic Network in the USGS for over 6 years. We offer actually 3 products related to the earthquake early warning applications. The first is a connection to the USGS ShakeAlert system, where we take the alert and port those alerts directly to other machines for direct machine-to-machine actions for automatic operations. The second product, which uses the same piece of hardware and software, can actually detect damage in your building or facility after an earthquake occurs. So imagine the value of knowing if your high-rise, for example, is safe to occupy after an earthquake has passed. And that assessment happens within seconds following the earthquake. Then our third product, we take the output from both of those 2 previous products and make it available to you wherever you are. So if you're at your desktop, your laptop, your mobile device, etc. Next slide. We connect this very complicated drawing anyway, or this figure, just shows that we're connecting to the USGS ShakeAlert alarm through an internet connection using the cloud. We take that and port it directly to our users. We also maintain a connection there for periodic updates and heartbeat monitoring. Next. We have 14 systems online in Washington and Oregon. We have about another 20 in process. Next slide. And our customers primarily are water systems, school, and government agencies at this point. We have more uses coming in hospitals and airports. But some of the unique characteristics of our clients and applications, all of our users are fully fault tolerant. So the actions they take don't cause damage and they don't cause an inconvenience to those organizations or customers. Our products are fully air-gapped, so there is no risk of cyber attack or other malevolent actions within our customer systems. We have the unique ability to filter out false alarms, and we do this with an on-site seismic sensor where we actually verify the P wave passing our customer locations. We use that same seismic sensor to identify damage in the facilities as well. And because all of our users are fully fault tolerant, they're all set to the minimum threshold values, so we maximize the time that each of our customers have to react to the quake. And generally speaking, what our customers are doing is we have many that are water systems, and in those applications, they're closing reservoir valves. That's so the contents are not lost downstream when pipelines break. And we stop pumps and motors to minimize damage during shaking. We activate public address alerts in schools, and this is especially important for special needs students to give them additional time to drop cover and hold on. And we have some government applications where we're making personnel alerts and providing some elevator overrides where we take the elevator to the bottom floor and open the door. And thank you for the time today, and congratulations to ShakeAlert for their public rollout.
Oh, thank you, Dan Irvin. All right. And next up, we have Dan Dalton with Valcom.
Thank you, Maximilian. Good morning, everyone. My name is Dan Dalton. I am a National Sales Support Manager with Valcom. And I am born and raised and reside in Southern California, so I'm very familiar with earthquakes, have a high respect for them, and what we're doing here to prevent life and property damages. So thank you for what you're doing. Today, I'd like to go over just a bit about Valcom, who we are, what we do, basic elements of Valcom, and a high-level overview of Views. That's Valcom's earthquake early warning system, powered by ShakeAlert. Next slide, please. Valcom was founded in 1977. We are based out of Roanoke, Virginia. It's where we design, engineer, develop all of our communication systems to keep people safe, informed, on schedule through audio and text messaging, and where possible, accompanied by automated actions. The strength of Valcom is simply getting an immediate message out to every ear and to every eye. All Valcom products are built and supported out of our offices and manufacturing facilities in Roanoke. Our products are sold worldwide to manufacturing facilities, warehouses, retail, government, utility providers, transportation, K-12, higher ed, we're real large in that, and more, essentially every vertical. If there's a need to get an audible or a visual message out, we're those folks. Since day one, our products have been developed on the philosophy of listening to our customers, and therefore we've built our company to where we are today. Next slide, please. With an array, and here's what I'd like for you to notice and take real close note of, is the LAN and the WAN. Our strength is immediate notification to every ear and every eye within your network, be it local or wide area. So our reach is as far as you would have it to be. If you notice some of the endpoints we have, from speakers, IP speakers, analog speakers, whatever the need is called for, we have those type of speakers. Notice clock speaker combos to be able to keep people on time and such. Strobes, a variety of different strobes, interior, exterior, for visual notification. And also, if you look below that, the LED sign, that is a all built-in sign, scrolling LED sign with flashers on the side to catch your eye so you can look to see what the message is. And there's also speakers built in, both paging and intercom, depending on what you want to program it to be. And I'd like to point out the attachment to it. It's an add-on, a threat level indicator. So those could be added to all of our different displays. We have standalone for the hearing impaired. And notice to the left of that, the V-Alert. We have an app we can push out to. And next to that is desktop alerting. So however we need to reach the ear and the eye, we have that ability within our own product line. Next slide, please. And if you notice here, a means of interfacing with third-party or legacy systems, whether it's an existing paging system, whether we need to reach out to a speaker array, even push out to telephone handsets, both audibly and visually to the LEDs, along with, in often cases, especially we're seeing this in the K-12, where we're pushing out to security radios, emergency notification for all different emergencies, but we're talking views here, definitely get out to radios also. Next slide, please. Machine to machine. So, we've heard about, notifying machines, whether we're turning off valves or we're slowing down a transit or an elevator or having it go to the bottom floor. All of that is capable within the Valcom family. So we integrate with third-party systems, with other systems very well. Another strength is we are CAP compliant, our software. CAP stands for Common Alert Protocol. That's the protocol that we use in our North American emergency system. So we can talk to other systems by way of CAP. For instance, NOAA, we're looking at protecting from tsunamis. So Amber Alerts, those kind of things. That's all built into this platform. Next slide, please. The software, okay, this is kind of the nucleus around all of this. The system is controlled by Valcom developed software out of Roanoke, Virginia, which we also we can enable views on top of that software. So it's just an enhancement to our software. When completed, a Valcom communication system allows flexible, ad hoc, scheduled, and emergency messaging to meet your organization's needs for business or education. Through the system's integration of audio-visual endpoints, interface gateways, and software, one can combine audio and text messages with automatic mechanisms to address schedules, daily routine, just daily communications. But in the event of an emergency, have predetermined emergencies from earthquake early warning to lockdown, shelters in place, etc. And to standard just bell schedules themselves. Maybe for your warehouse, you've got lunch schedules and things like that, all built into the same platform. And we talked a little bit about tsunamis. That's super, super important to keep in mind when we're talking about earthquake early warning and the effects of the tsunami, where our software has the ability to receive tsunami messages and act on that, push it out. How would you like it to push it out? And who would you like us to integrate with? We've got a lot of partners here we can integrate with. So all encompassed, we have a pretty powerful team here. Next slide, please. Now let's turn a little bit to the discussion of Views, what that is. Views is Valcom's earthquake early warning, powered by ShakeAlert and the USGS. So simply said, ShakeAlert sends a message via the detectors quickly by way of the P waves. Information is generated to the USGS servers and sent to Valcom's cloud. Valcom propagates the message out to our end users to deliver on-premise earthquake early warning actions. Okay, and it's just quite that simple, real quick and easy. Next slide, please. Now, notice down at the bottom left, just kind of depicts how everything's going to flow. Views interfaces with the USGS ShakeAlert system to receive information at Valcom's secure and redundantly backed up cloud infrastructure, where a user's desired modified Mercalli intensity threshold, the MMI, for earthquake early warning alerts is stored and secured. Encrypted messages are generated to send to our on-premise systems. Based on the delivery and the needs of the customer, the MMI values can be adjusted within our software for the expected intensity level. And if you notice the on-premise software that will reach out to speakers, horns, flashers, desktop alert, and automated actions. And notice the alert message from ShakeAlert. You'll see that the message will be preceded by a tone. This message you can receive on our LED signs, on our screen pops, etc. Next slide, please. And this is where I say thank you all for your time. I appreciate you taking your time out of your day for us to be able to present to you our solutions and Views and ShakeAlert and USGS or earthquake early warning. Thank you all.
Thank you, Dan Dalton. All right, and next up, we've got Taylor with RH2 Engineering.
Thank you. So I work at RH2 Engineering. We're a Northwest civil engineering firm, and we're going to tell you about our work with ShakeAlert over the last 5 years. My lead role here with ShakeAlert is in projects and in executing those, and also work on just infrastructure projects throughout Oregon and Washington. So I promise, though, take a quick stretch, right? I'm your last presenter here, and then we get to questions and answers. We'll keep this quick, and I'm going to start with a story. So about 7 years ago, I was leading mechanical design on one of those infrastructure projects. It was a water tank, but it had an earthquake problem. The city we were talking to them about getting an earthquake sensor and valve on the tank. And this is 7 years ago. Okay, so before ShakeAlert, there would be kind of a local sensor there that it's not going to receive the signal. It's not going to be able to alert you, give us much warning time, but it's better than nothing, right? If you can close that valve, like's been mentioned here a few times, on that water tank, then you preserve, in this case, 6 million gallons of drinking water for emergency use after the earthquake. If you don't have that valve being able to close, then probably the older pipes in the system are going to break in the earthquake, and that tank's going to drain pretty quickly. And so the city, though, got focused on all those older pipes, and everything else in the system that was not going to survive an earthquake. And it's understandable, though. I mean, their sentiment was, why spend the money, the extra money, on making this one bit of the system stronger when the rest is just going to fail anyway? Next slide. So you might understand this sentiment as expressed by your neighbor, right? Like, why make a 2 weeks ready kit? Why make a go bag when my brick house is just gonna collapse on me anyway? And this fatalism is common, it's dangerous, and a 3,000-year-old proverb gives us some insight. It says, where there's no vision, the people perish. And that old word perish actually can mean have no discipline, right? So why be disciplined to spend a little extra money on something when there's no good outcome? RH2 saw the opportunity to change outcomes with ShakeAlert. And so around 5 years ago, we started working with ShakeAlert. And over the last 3 years, we've been installing applications throughout the Northwest. Here's a quick slide, if you go to the next one, about various places where we've got in Oregon and Washington. And I was down last month with a client, and their question was, why aren't more utilities using ShakeAlert? Well, it's getting started. Next slide. So the left side of this slide, we're not going to take a lot of time on. This is the same foundational system that we've been talking about here. That signal getting out into the network that's giving some information about the earthquake. RH2 then here in the orange box, we're going to focus on the right side of the slide, right? Again, a secure air-gapped connection to the control system for a water, wastewater utility, other utilities. And that signal then can arrive really quickly, 4 seconds, something like that, quicker than a wireless emergency alert. And with that, then you can take action, which is our next slide. Again, this is at various utilities. We're going to use water as an example here. Our clients have been setting up the control systems with various actions. Most are alerting staff. They're closing valves, like we talked about in that tank, and they're shutting down equipment to avoid damage to that equipment, risk of fire, and taking other automated actions to protect the system. And each month I hear about new ideas. It's just a lot of enthusiasm once they catch a vision for resilience. And it's that kind of enthusiasm, that growing resilience, more and more actions that we all want for our state, right? So let's replace fatalism, we talked about earlier, with vision on both the infrastructure and personal preparedness fronts. What can you do, right? I mean, like I said, get that on your phone. Tell your neighbor about that. And tell your utility about ShakeAlert and RH2 engineering for automated actions. Next slide. We've been serving the Northwest for over 43 years, very resiliently, right? So our patent pending controller to harness that ShakeAlert signal is just a newer tool to help our clients. We support utilities and other providers of infrastructure, critical services with over 100 professionals throughout the Northwest here. Headquartered in Washington, and our focus, like I said, is water, wastewater, transportation. So this breadth of services and longevity and relationships that RH2 has had here is what drew me to it years ago. But let's talk back about years ago. So that water tank, going back to that story. The city ended up catching the vision, and they decided to install the valve and sensor. The biggest impact, though, was that whole conversation on their mindset. They embraced the vision with the tank as a beginning of resilience, and they made it a hub for emergency water supply to their system. This came in handy just a few months ago. Earthquake, you say? No. Remember the snow and ice storms? Yeah. So they lost power. But because of the connections of that water tank with a neighboring utility, since they had invested with that view of making it a resilient hub, they were able to supply water to their city. And the same is true here, right? Multiple fronts, ShakeAlert can benefit each of us. So thank you, each of you, technical partners like ourselves, licensed to operate folks, for spreading this vision of resilience to multiple sectors. And thank you, attendees and Washington folks, Washington Emergency folks, for getting this out to everybody. We want each of you to take this vision of resilience to your neighbors, right, and to your utilities. And please reach out if we can help in that. Thank you.
Great, thank you, Taylor. Much appreciated. And that concludes our presentations for today. I have some information here. Again, we've got, if top left here, earthquakes page, for all more information on the wonderful products and services that have been presented here, please go there. And also for earthquake information, how to protect yourself. Bottom left here, alerts, all things, how to get signed up for alerts, how to make sure that your phone is going to receive earthquake early warning alerts, all that good stuff. Please go there. We update it every week. Also, top right, if you have questions, please reach out to us at public.education@mil.wy.gov. Follow us on Facebook, Twitter. Check out our YouTube channel. We've got a bunch of videos. This has been recorded, so we're going to put it up on our website. So we're going to make this available. So again, please check out our websites, and thank you for joining us. And now we're going to start our question and answer session.
Hi, everyone, and thank you so much for joining. My name is Dante DiSabatino, and I'll be reading some of the questions you all had to our presenters. The first question I have is for Harold Tobin with the Pacific Northwest Seismic Network. How soon can a wireless emergency alert be sent to all users after ShakeAlert detects an earthquake?
Yeah, thank you for the question. There are a couple of different parts to that. The ShakeAlert detection itself, as I kind of outlined, depends on the earthquake location to some extent, but happens within a few seconds and maybe a couple more seconds to issue the alert. That is, the way the system works is that is essentially, we call it published to a server that then is being listened to by various other systems. The wireless emergency alert system has a variable amount of time for the delivery through the various gateways to end users, and it's unfortunately I can't answer it well myself because that's very far from being under the Pacific Northwest Seismic Network's control. The range may span from just a few seconds to a substantial number, tens of seconds or more, for the delivery to end up in end users' hands with the WIA system. The Android system is a different pathway, and user experience in California so far has been that that's a faster delivery mechanism for under certain conditions. The WIA system is also a system that was designed for other kinds of alerting, not earthquake early warning, and there is continual work going on right now to increase the speed and efficiency through that system of how the alerts are actually propagated through it and pushed out to the cell towers and therefore mobile devices. So that's the best answer I can give. It's not an exact number. There is no way to give a single exact number for that answer.
Thank you very much. I do have a question here, a couple of them for Maximilian Dixon with the Washington Emergency Management Division. The first one was a couple of questions about the WIA test in February in Washington. So what was the test message that was sent in February? I had my alerts turned on, but I didn't get anything, is the first question.
Oh, yes. So it was a test message, and what it did, it had a hyperlink to our alerts page, so folks could click on there to find out more information. So it was just a very simple test message that went out.
All right, thank you. And then another question here I have for Boone Spooner with Google. How about my Android tablet? Will that work for Shake Alerts?
At the moment, it is set up only for phones, mobile devices. We are looking at expanding that in the future.
And another one for Boone with Google. Does the earthquake location option in settings depend on your phone type?
Does the no, it shouldn't. Well, it is Android based, I should say that. The earthquake alerts option is available for all Android devices running Android OS 5 and up. So that's Lollipop, which was, it's quite old. So it's like 99% of Android devices. So it should be available there under settings location. You should be able to see it.
All right, and I do have another question here. Can Android alerts be sent to Canadian cell phones, or are they restricted just to the US carriers?
So the Android alerts in partnership with ShakeAlert are only available in California, Oregon, and soon to be Washington.
Thank you. We do have a general question for our partners on the call. Will these alerts be going over systems like SiriusXM or OnStar?
That's a question for.
I think we're going to have to do some research on that one because there's so much technology and this is emerging very quickly. So I think we will research that and get back to folks and provide some information at a later time.
All right, here, let's take a look at a couple of other questions. If we had a Nisqually-style earthquake and I was in Shoreline, how long would the notice be before the earthquake hits?
I can take a crack at that. If we had a Nisqually-style earthquake and the epicenter of the earthquake was in the same place as Nisqually, so there are different locations, of course, that the next earthquake can happen closer to or farther away from Shoreline. But having said that, then combining the time to actually detect the earthquake and then the time to issue the alert and have it actually arrive at a phone, the last part of that, the arrive at a phone, is the part that's a little bit of variable depending on which alert modality, which alert mechanism is used. But we can generate an alert for a simulated Nisqually event with anywhere from something like, and this is, to some extent an estimate, 8 to 12 or so seconds. That we use that number based on downtown Seattle. So with Shoreline, add a few seconds to that. So something greater than 10, 12, 15 seconds is plausible for a Nisqually-style earthquake at your location.
Thank you. And I have a couple of questions. We'll start off with this one. Which of these systems would be best for an individual, so not businesses? Maximilian Dixon, would you like to take this question?
Yeah, I mean, the public alerting options that we went over obviously was the wireless emergency alerts. So that's, Amber, Tsunami alerts, earthquake early warning. So all of those, please, as I described, make sure that those are turned on for your mobile device. And then, of course, if you have an Android device, you've got that whole capability with multiple different types of alerts. So those would be your easy options for alerting yourself. If there are other things that you want to be alerted for or automated actions, then I would say there's a suite of options. But those are the simple, most, I think, comprehensive for helping you to understand that, hey, shaking is coming your way and take protective action. So those are the simplest ones for wireless emergency alert and if you have an Android device.
And another question for you. Once the shaking stops, do you recommend one stays put where they are or leave? I live in a high-rise apartment building downtown.
Yeah, good question. So, it's tough to really give people recommendations because you can literally be in just about any type of situation you can imagine, right, when the shaking is happening. So if you're, for example, in a high rise, what you want to do is after the shaking stops, you want to, of course, check yourself for injuries because your heart's pumping and, adrenaline's going. So check yourself for injuries, make sure you're not bleeding, do some basic first aid if you can, check other people around you, check them for injuries to make sure that they're not bleeding out. And then, of course, check out your surroundings to say, hey, is there smoke? Is there gas? You smell gas? You see fire? Is there dangerous conditions? So you want to do is get away from those dangerous conditions if they exist. And then, don't use elevators because elevators are most likely being not working or damaged or unsafe. So make sure you walk down the stairwells and be careful, pay attention, go cautiously if you can. If it's a dangerous situation, obviously move as quickly as possible to get out of that dangerous situation. And then, of course, watch for hazards. And there may be large aftershocks. So make sure that you are aware of those so you can protect yourself during an aftershock. And then, of course, if you happen to be in the tsunami inundation zone, get to high ground as quickly as possible. Obviously not in the high-rise tower situation, but just wanted to mention that. So those are what I would recommend for that situation.
Great, thank you. We do have a question which I'm going to open up to the whole group. Is it really true that cats and dogs could provide an early warning of a couple minutes by acting out super out of sorts?
I'll tackle that one first. The fact is, it is not true. We know very well that cats and dogs sometimes sense or feel the P wave that humans are just a little less likely to feel, but that's the same thing we're using as the earthquake early warning system detection through seismometers. Amazingly, there's actually been significant research looking at animal behavior and whether they have some sort of a premonitory earthquake sense, because that's been such a kind of a piece of I'll call it urban lore or societal lore. It's not true. We don't have any evidence whatsoever that there's anything actionable we can use based on animal behavior.
And speaking of animals, make sure that as you're creating your family emergency plan, you're getting prepared. Think of your pets to make sure you've got items for your pets. We love our pets, so make sure you're thinking about them to be able to make sure that you have all the stuff that you need. And then, of course, follow your family emergency plan. Develop it, practice it, make sure everyone knows it, so you can follow it when the next earthquake happens.
And I have another question here for Boone Spooner with Google. What Android version do I need to have to receive the ShakeAlert powered alerts through my operating system?
Right, so it's Android version 5.0 and up, which is quite a number of years old. We're on Android 10 today, so it's quite an old version of Android. It will cover about 99% of Android phones.
I have a question. I'll kind of direct it towards Alert FM. The question is, I'm a homeowner living on the Sound. I want to protect all my elderly neighbors. Is Alert FM best to buy?
Yeah, it's ideally suited for, this is Matthew Streb with Alert FM. So it's ideally the personal receiver that we demonstrated is ideally suited for in-home use. So it would stay in the home, in the kitchen. It also is very useful because it'll wake you up during the night, even with the cell phone switched off or other devices you may not be able to hear, like a siren that's outside. So the answer is yes.
I have another question here, and the question is, if an earthquake happens in, say, Oregon or Idaho, will the ShakeAlert message still be issued in Washington State with areas nearby to the epicenter?
Yeah, that's a great question. The ShakeAlert system is a seamless detection system that spans California, Oregon, and Washington, but also that means that it detects shaking from earthquakes that actually the epicenter is outside the border of those three places, including in Canada and potentially in Mexico. So when an earthquake happens where the system automatically calculates that ground motion, meaning shaking, large enough to potentially be damaging, will occur within the boundary of the warning zone, then that warning will be issued. That does not mean that the warning itself will span across the border. So for example, unless your phone is actually connecting to a cell tower within Washington, Oregon, California, when you're just outside the border, you would not receive the message even for an earthquake within the border. So it's about the location of the receiving device, whereas we calculate the earthquake shaking just depending on shaking within the boundaries of the three states.
Thank you. We do have a question here is, what should you do if you're out on a boat?
Yeah, good question. So if you're out on a boat, it really depends on the type of earthquake that happens. So for a Cascadia subduction zone earthquake, the big one, hopefully you've got your marine channel 16 going and you're going to get that alert. You've got a NOAA weather radio on you on your vessel so that you receive that alert, that tsunami alert, that a tsunami is on the way, because you may not feel the shaking. You're going to be out in the water. So in that case, if you hear or receive receive a tsunami advisory or a tsunami warning, which essentially says that a tsunami is on the way to your location, then you're going to want to do is get to either, if you're out in the open ocean or out in Puget Sound somewhere or the Strait, get to as deep a water as you can. So ideally 600 feet deep or more, and then you stay away from other vessels, and then try to ride out the tsunami as best you can. And remember, there's multiple waves over maybe 12, 24, maybe 48 hours. So hopefully you've got enough food and water and supplies on your boat. Now, if you happen to be near the marina or the dock, or you are docked at the the marina or the port or whatnot, then get off your vessel and get to high ground as quickly as possible, because you want to make sure that you are safe from the tsunami. Now, if it's a small earthquake or a deep fault earthquake, or you may see trees shaking or telephone poles swaying out on the coast, and if you don't receive a tsunami warning or a tsunami advisory, right, so check for those. But if you don't receive those, then again, just get prepared just in case there is a tsunami and you simply didn't get the alert. Again, trying to get to deep water, and then let's stay tuned for more information and figure out what happened and whether there's a tsunami warning or advisory. Then if there isn't, then of course make your way to the port or wherever you're going to go, and just make sure that you are hopefully can help other folks if they need help, and that's the advice I can give you.
Great, thank you. We do have another question here for Boone Spooner with Google. Is the Google sound different than the wireless emergency alert sound? When the earthquake hits, will we get two different tones or just one long tone?
That's a good question. It is different than the wireless emergency sound. It is a specific earthquake sound for Android devices, and I encourage you, if you have that or an Android device, to go into the demo and hear it. It is possible that you could get the Android alert and the wireless emergency alert at the same time or near time together. They would be obviously two different tones at that point. Yeah, and I think that's covers all the answers there.
Thank you. I do have a general question here. Will ShakeAlert eventually be in other states with seismicity or expand into Canada?
I can tackle that. Right now, ShakeAlert is authorized and funded for the 3 West Coast states that it's live in as of next Tuesday. Canada is independently working on and has funded an earthquake early warning system that is using much of the same computational technology as ShakeAlert, and in fact is partnering with the US ShakeAlert system. As far as other states go, there is a lot of, I think, desire to potentially expand the ShakeAlert system into other places besides the 3 West Coast states, but there is not appropriated funds or a concrete plan to do that right now. So states adjacent, East Coast, et cetera, other regions with earthquake hazard, Alaska, and so on, we would love to see it happen. It isn't in the works yet that anything we can announce.
Thank you. We do have another question here, and it says let's see here. So to elaborate on the stay or go question, when you say you should leave the building you're in, where are we supposed to go? I wouldn't know where to go if I left where I lived. As long as there is no dangerous situation in my building and house, is it best to stay where I have more resources like water and food?
Oh, absolutely. Yeah, great. Thank you. I appreciate you bringing that up. So again, very complicated, can be so many different situations that you're in. So essentially, if there are no serious hazards or threats or dangerous situations in where you're at in a building, then yes, stay there. Find, hopefully follow your family or your work emergency plan. So hopefully get those out. You've practiced those, you've developed those. So follow those plans on how you connect to out of area contacts, say by texting, to be able to share information. If you know you've hubs or areas where you know in your community that there's going to be supplies or sharing of information or places that you can go for shelters and whatnot, then if you need to, or if you want to find out information or you want to go check in, you can go do that. But yeah, if it's safe, stay there. Hopefully you have supplies, get oriented, get information, follow your plan. Absolutely.
Great, thank you. I do have another question here for Boone Spooner with Google. I don't see the Google earthquake alert on my Android phone. Is it possible that it won't appear until after the rollout on May 4th?
That's correct. The setting will appear on May 4th and beyond, and it might take a few days for it to roll out to 100% of devices.
Thank you. And another question for you, Boone. Does Google Maps have evacuation routes integrated into their system?
That's a good question. I don't have that information in front of me at the moment. I don't know if there's a way to respond later.
Feel free to email us at public.education@mil.wa.gov, and we'll be able to forward that question.
And to clarify, you're talking about tsunami evacuation.
It was not specified.
Okay.
All right, I'm taking a look and reviewing some more questions here, so just a moment. Are there currently any mobile applications available in Washington State?
No, not currently, but we hope to some point in the future.
And here's a question. Do wireless emergency alerts break through the do not disturb, vibrate, silent settings on iPhone and Android devices? And a second question to that is Android, it says here, Android will send the action alert with a magnitude 4.5 plus. What is the magnitude that will take WIA to send the alert?
Yeah, I can tackle that one. So for wireless emergency alerts, it's really tricky depending on your device and your carrier. So, unfortunately, there's instances where you could be roaming or you're watching something or you have do not disturb turned on. So we actually don't have the answer, unfortunately, to all of the different type of situations that your phone could be set to that would, either prohibit you from getting or block you or for some reason, not allow you to receive the wireless emergency alerts. But hopefully if you turn them on and you've got, the settings all good, then it will pop up like an Amber Alert. So if you've received those. So I think that's the best we can give you. We don't, Washington Emergency Management Division and nobody here that's presenting actually owns and operates the wireless emergency alert system. So that's the information that we have available. As far as thresholds, it's a minimum magnitude 5 earthquake, and then intensity MMI 4 or greater, as to my understanding. Harold, is that correct?
I had to find the unmute button. Yes, that's correct.
Great. So for clarification, that means a magnitude 5 or greater earthquake for the earthquake itself. And then we're talking about intensity levels. That's how intense the shaking is expected to be at your location. Right. And so, again, let's talk about a little bit about what that means. Right. So if you think about a light bulb, right, you got a 100-watt light bulb, and the light bulb, 100 watts, that's your magnitude. So say magnitude 5, 100-watt light bulb, right? Then that applies for everyone everywhere, because that's the amount of energy. That's the earthquake. Now the intensity is, if you can think about it, is how close you are to that light bulb. So if you're really close to that light bulb, it's really intense. It's shining right in your eye, right? So that's really intense. So that's a high intensity. If you are far away from that light bulb, or the further you are away from that light bulb, the less intense that is. And so you have that earthquake happens, and the folks that are really close to it, and they have that high intensity, they're going to receive an alert as long as it's at MMI 4 or so that light shaking or greater. But folks further away who may not are not going to receive that type of shaking, maybe just less shaking, then they're not going to receive an alert. If that helps explain a little bit.
All right, thank you so much to all of our presenters today. We do not have any more questions. Maximilian, if you wanted to close it out.
Yeah, absolutely. Thank you so much, everyone, for attending the presentation. Thank you, all the presenters. Wonderful information. You did a fantastic job. Again, this is been recorded, and we will be putting it up our website. We're making it available. Please reach out and go to these links for more information. I also want to do a plug. So UW, University of Washington Pacific Northwest Seismic Network, they are having an event on May 4th, so the rollout day at 6:30 p.m. It's titled ShakeAlert Comes to Washington. It's a Facebook Live event, so please check that out, and a few of us will be presenting there. So thanks, everyone. Stay safe, stay healthy. Thank you so much. And remember, you can survive if you get prepared. Thank you.